Rational functions, part 3, vertical and horizontal asymptotes. Recall that vertical lines have the equation of x equaling 4 and horizontal lines have the equation of y equaling 2. If I was to graph that in graph 1 over here, x equaling 4, 1, 2, 3, 4, I would have a vertical line right there, x equaling 4, where every point on that line has a coordinate of 4. This point would be negative 1. A point up here might be 4, 4. A horizontal line crosses the y-axis, in this case y equaling 2, where every point on this, maybe that's a negative 1.5, comma 2, or over here we have 2, 2, where every point on this line has a y-coordinate of 2. So asymptotes then are lines that a graph approaches as x gets larger or smaller, and sometimes the graph will cross an asymptote. Let's take our example, f of x equaling x minus 3 over x plus 5. You can pause this and take your calculators out and type that in, view it during in a standard viewing window, and you get a graph that looks something like this. Now it appears that this graph over here is approaching some vertical line, and as we go right here, it's approaching some vertical line. Well, that vertical line is an asymptote, and that, in this particular example, this asymptote occurs at x equaling a negative 5. Horizontally, there appears to be a line that this graph approaches. That line happens to be y equaling 3. So let's analyze a vertical asymptote, and if time, we will analyze how to find a horizontal asymptote. The vertical asymptote is going to occur when the denominator is undefined, that is, when it is equal to 0. So let's take x plus 5, set that equal to 0, and when x is a negative 5, we should have an asymptote, as we did on the previous page. So what we're actually doing is we are saying when the denominator is 0, so when x is a negative 5, we have an equation that is undefined. Graphically, 1, 2, 3, 4, 5, negative 5, we have this line that our graph will approach. As x gets smaller, the graph will approach it, and as x gets larger from the negative side, negative 10, negative 9, negative 8, negative 7, negative 6, our graph will also approach it. So let's move on to horizontal asymptotes. Horizontal asymptotes occur under one of these conditions. If the degree of the numerator and denominator are the same, then the horizontal asymptote is the lead coefficient of the numerator divided by the lead coefficient of the denominator, as is the case in our example, as you can look below. Both numerator and denominator of degree 1. If the degree of the denominator is larger than the degree of the numerator, then the horizontal asymptote is 0. And we will discuss that later. So in this particular example, our horizontal asymptote, y, equals lead coefficient of the numerator over the denominator, which is 1. And if you take a look at the graph, we had a vertical asymptote at a negative 5, and the graph came up and approached this horizontal asymptote, y equaling 1. And then over here, the graph, or hyperbola, had that curve. Please notice that when we make asymptotes, we use dotted lines, and pardon my line for not being dotted in certain areas.